Okay, welcome back. Hope you had a nice weekend. Before we get to the main content for today, would anyone like to bring up anything to discuss or ask any questions about assignment 4 or any of the material we've gone over so far? As a reminder, assignment 4 is going to be due this Wednesday at midnight.
I had some questions about assignment 4.
Okay. Go ahead.
Where is it? Okay. So for the serial position curves, for the lists or the data sets 15.2 and 31, I am getting a single value that is for one word higher than the list. And as far as I know, there isn't a way to know how long the word list is just from the data frame alone, because the number of columns doesn't necessarily correspond to the word list.
Yeah. So okay, so in the SPC function, serial position curve function, there's a cond argument. The cond should be set to something like 10-2 or 15-2 or 30-1.
But it's optional. So if someone just specifies a data frame without the cond argument, so someone specify, for example, 31 without any cond because it's entirely optional, then you would have this issue.
Yeah,
arising.
That's right. So if if they don't specify the condition, then one way to estimate the list length would be to ask across all participants and lists, what's the maximum number, recall number? Like, what's the last list word that anyone recalled? So like, if no one recalled a list item greater than 20, then...
But the issue is one of those, like list word 15, it's word 16 appears once. And I think it's supposed to be filtered out earlier because it's mentioned one of the functions that you're not supposed to add in, but that for here's a bit of code that for when it loads in. This is when it loads in the Murdoch data. But I think this is incorrect because int x equals 88 will never run since it's always greater than 0. So I was wondering if that's supposed to be if int x is greater than 0 and it's less than the length of the list, or it's equal to 88.
So that's so. This is in the when I'm describing the Murdoch data set.
Yeah, this is the load Murdoch data set that occurs earlier. It's one of the sort of helper functions that's defined early on. I'm trying to find, if you go to the section Murdoch 1962, if you recall, and it says,
that's just filtering out like negative numbers and zeros, which have a different meaning in that data set.
Although it says any other invalid entries, for example, values other than 88 that are greater than the list length or values less than or equal to 0 should be ignored.
That's right, but that's by you. That's not part of the pre-processing that I do.
Okay.
So here's the way I would recommend implementing the serial position curve function. You can I'm not going to test that function for some case where I don't pass in a condition name. I may use a different data set to test your function. So like your function should not be specific to the Murdoch data set. It should be general enough to accommodate any data set of kind of the same general format with the same condition naming scheme. But you can assume that I'm going to pass in a condition name that's equivalent to something, to like the Murdoch condition names, where the list length is like the integer of the thing before the dash, of the number before the dash. So like if you split the condition string, if you do like condition dot split of hyphen of 0, that'll give you the string of the thing before the hyphen, and then you can just call int of that, and that'll convert it to an integer, and that'll give you the list length.
Okay, thank you. Let's see. Okay, and then I have a weird issue. I don't know if this will be debuggable or not, but I don't know if it's just me or if anyone else has this. This is what my so this is what you're supposed to get for that graph thing at the end, and this is what mine looks like.
Wait,
the error bar
for
is one of them, and if it were all of them or it were more, I'd be less worried, because I'd go, oh, I feel like there's an obvious place I screwed up. I don't know where I messed up here, that it's just one condition that's different.
Wow, huh.
And I don't know if anyone else has done this, and if anyone else has had this issue, or if anyone has done this and has gotten it perfect.
Yeah, I'd like to know too.
Yeah.
There are some tricky cases to deal with that I guess I would have expected them to come up in other conditions too. But like if you recall, let's say you have like a 10 item list and you recall 1, 2, 1, 3, 4, 5 or something like that, then you have to take into account that the first item was repeated, so that doesn't count twice.
Oh, yeah, and I didn't do that, so you know what?
Okay. Okay, so that could be
where it is. Although
that could be it.
Weirdly, that is only affecting one condition, but
I'm surprised that it only affects one condition. Interesting. Yeah, I mean, you're welcome to like post the code, your code on Gitter, or like, you know, I mean, we could talk about it here too if you want to go over your code, but yeah, it's kind of up to you, or you know, email with it or reach out with a specific kind of.
I can after class I'll try to add that step in there to get rid of any duplicates, and then I'll post an update in the Gitter if that solved it, or if I'm still having that weird issue.
Okay. Did anyone else attempt that and either match or not match the figure I had posted?
I was able to match it, but it definitely took me a really long time. Like I was also having issues where mine were much bigger than they were supposed to be. But if you want to talk of like, if you want to compare codes later, Sarah, let me know and we can see. Maybe I'm also doing it wrong and I just think it looks right, but I think I finally got it.
Thanks.
Yeah.
So one of the weird things is like the error bars are specified as a lower and upper boundary relative, I think it's relative to the mean. And so you have to take off the mean when you're specifying them, which depending on if you have like a positive or a negative value can be very, very annoying to deal with. But like a good I mean, it looked like you actually passed the sanity check already, but one thing that I like to check is like, you know that the maximum recall accuracy possible is 1. So like you could even make a fake data set where you have a recall accuracy of 1 and make sure that the error bars don't go above 1. And then you also know that the minimum recall accuracy is 0. And so you can also make a fake data set or even analyze this data set and make sure that like the error bars don't go below 0. So if you plot like 99.9% confidence intervals, you know there's going to be like one subject who recalls everything and probably at least one that doesn't recall anything, but the error bars shouldn't go past the possible range. But it's easy to have them go outside of the range if you're like subtracting the wrong thing from the, it's easy to get it wrong. I'm surprised that it only affects that if I'd be surprised if you're encountering that, given that it's only affecting like one condition, but yeah. Okay, cool. Anything else?
I had a quick question, especially regarding the public rubric that you posted. So I know you have like, it's like X dot the data set, like the MNIST data set. And I wanted to confirm that that's still the same data set that's being referenced.
Yeah.
Only because
Yes. Yep.
you can. Yeah, I was going. Okay.
Just remove the X dot. That's part of the auto grader thing. Yeah. The idea there.
So in that case, I'm somehow able to recreate the heat maps that you have, but then the values that I get are completely different than what you have in the rubric. So I'm just wondering if anyone else had that issue and if you have any suggestions for how to go around debugging that, with debugging that. Because I'm really not sure what I'm doing wrong now.
What are do your values range from 0 to 1 instead of 0 to 255, maybe?
I have to reload my notebook, so it takes a second, so I can check and see if that's the issue. But yeah, it's a completely different scale, but still the maps look the same. Maybe that's it.
Okay, it's possible that once I posted that assignment, I tried rerunning my solution like before I sent it out to you guys, and it failed because the website that hosted the data set stopped, like it went down. And so I kind of quickly put together, like it's a relatively widely used data set. And so I like found it somewhere else and then I kind of wrangled it into the same format. But it's possible that one of them is normalized by like to go from 0 to 1 and the other might be, range from 0 to 255. Those are kind of two common ways of storing the numbers. If that's the case, then I'll accept either solution, but I'll probably have to do something manually. So it might delay getting feedback for a little bit, but yeah, if your heat map looks correct, and either it ranges from, something that looks like 0 to 1 or roughly 0 to 255. And if the scale matches the original data, then that'll likely be correct.
Okay, thank you. Yeah, mine does seem to range from 0 to 1. So maybe it's something else. I can double check that. Thank you.
Sure. Sorry about that. That's I didn't catch that. I just looked at the picture, the like image pictures as I was like frantically fixing it because I was like, okay, people are going to start the assignment and there's no data, like that will getting the data set will crash everything. So okay, lovely. Anything else? All right. Okay, so good luck finishing that up, and we'll have some time on Wednesday to ask any final questions, and then the assignment will be due midnight on Wednesday. Okay. So next, I want to give Chris and Courtney a chance to show us their like Bob Ross hackathon stuff. Actually, I don't know if Courtney's here, but okay. Well, Chris, if you're up for saying a quick something, since we ran out of time on Friday, and then after Chris, after we talk about that, then we'll spend most of today's class digging more into pandas and possibly scikit-learn, depending on how quickly we get through the material. Okay, so let's hand things over to Chris, and we'll talk about his Bob Ross hackathon stuff for a few minutes.
Cool. I will share my screen, get this going. Which one is it? There we go. Great. Can everyone, oh, now I don't know where it is. Can you see the Bob Ross screen, or are you looking at a paper?
It looks just like a white rectangle to me. But...
Oh no. Okay, hold on. Let me do this again.
It's one of those like invisible ink tricks.
Yeah. Okay, now
Titanium
I'm here.
white. Yeah.
Titanium white, exactly. That's the project. We just made titanium white. All right. Try to. I'm going to do Bob Ross. That. I'm going to share it. How about now?
Yeah.
Yes? Bob
Yep.
Ross is there? Excellent.
Yep. Oh, yeah.
So what we did, we were broadly interested in what we could learn about paintings and paintings titles in particular from the content of the painting in terms of colors. So we were broadly, I mean, it kind of has to be true, but we wanted to see what we could predict about titles or the content of paintings based on the colors used into them. So there has to be sort of some relation, or else like it would be nonsense paintings if like the colors used didn't change based on the topic of the painting. But we wanted to quantify and see if we were able to better predict some things than others, or and I'll get into future directions and things at the end. But one sort of like easy avenue to that we saw was to train a classifier to detect if there are different objects or themes in the paintings based on the colors used in the painting. So this, especially after working on assignment 4 a bit, I realized this could have been done a bit more efficiently, but we sort of split up training and test sets by hand here instead of using the nice function that does that for you. And then we used an SVM instead of a logistic classifier. So but to start, we sort of like used it like one would use a logistic classifier. So we just look for winter, but we have the capability, if you append to this object list, to look for other things. So if you wanted to see like here's winter and if there are conifers too,
nice.
Then just conifer, then you can add that. I'll start with winter now because more things work if you just use it like a logistic classifier. And then we run into errors later on. So right now we're just looking to see if we can detect if a painting is in the winter or not based on the colors used in it. So do a whole bunch of fun stuff with the data down here. This bottom one gives us, oh no, the bottom one there gives us what the Y values look like. So we're just testing if it's 0, not winter, or winter, winter. And let's see, how is this going to turn out? So we get a prediction accuracy pretty consistently of around 90% for winter. But if you look at this confusion matrix, you see that it does a really good job saying when it's not winter, but it's not doing as well saying when it actually is winter. So there seems to be some confusion there among the winter scenes, but it's pretty easy to say like, hey, this isn't winter.
So
And
I think, sorry, there's a important point here actually. You've probably heard of like sampling bias or like bias in machine learning. This is like a super important problem actually. So I think what's happening here is that winter paintings are actually relatively uncommon in this data set. Just like, a small proportion of the paintings are wintry. And so if you just always guess that, like if you didn't have a classifier, or it was a dumb classifier that just always said it's not winter and just ignored the colors, you'd be right most of the time. And so like your data set is biased towards non-winter scenes. So you're kind of training a binary classifier. So like an unbiased data set would have like a 50-50 chance of being winter or non-winter. But because the data set is biased, there's like, sorry, angry preschooler here. The wrath of, yeah. Oh, wow. Anyways, good Lord. Well, he's learning to communicate. Okay. Okay, I have no idea what I was saying. Bias, you don't want it. So
training bias, like the data set
bias.
More, yeah.
So one way to get around this is to take like all of your winter paintings. Let's say there are, 10 of them, and then you could select at random 10 non-winter paintings, and that would give you equal numbers of winter and non-winter. And that could be your full data set, which would be tiny, but it wouldn't be biased. So like the amount of unbiased data you can suck out of this is something like the number of your least, frequently observed category.
Right. And that's what you would, that's what you would test it on, or that's what you would train it on, and then would you test it on an equally like split data set, or how would that work?
Yeah, so that would be your total data set, and then you'd have to further subdivide that into a training and test set. Yeah, so you get a tiny amount of data. So probably, so one way to like think about this, if you wanted to publish this, would be like, maybe this data set isn't the right data set for this particular problem. But if you were like, okay, let's say it costs like, $10 million per painting to collect. So like you're not really able to collect many of them. Or it's like, you're studying some patient and there's just like only one of them. So you can't really like test, I don't know, you could test two people, like one person who's that patient and one not. You could just instead train your classifier, and then like the point of your paper could be like, when my classifier, like, is it just guessing that you're always not winter, or are the errors somehow interesting? So like looking into the errors more would be kind of the point of the paper.
Right, that makes sense. So maybe a better example would be to find one that instead of winter, maybe there's a different feature that does occur in like a broader, a bigger number of the paintings.
Yeah, that's, yeah, I think if you like wanted to get like a publishable result, that would be a kind of fairer approach. But like for just training, like practicing training a classifier, this is great. And
oh, awesome.
Yeah. So yeah, Doing great.
Cool.
Didn't mean, sorry for derailing. I just wanted to point out, because bias is a super important issue in like thinking about classifiers. So I don't think I mentioned that at this point. So, okay, carry on, sorry.
Oh, no worries, no worries. So we checked out, we got pretty good results, probably because it was biased. And then we used a, oh, I don't know if this is gonna work. Oh, this might get mad at me. Hold on. Let me change this to that. Now it should be ones. Nope. There we go. Now it should be ones and zeros. It'll be binary. Great. And now we can plot it down here to get our decision boundaries. So what we did here is we wanted to make like a nice plot of the decision boundaries. And so to do that, we just used PCA to reduce our like number of features to 2 so that you can plot them well to the first 2 principal components. Then you can plot those on a 2D graph, which is nice. And you can see which of those components are being used to select the winter paintings, which are the ones, the orange triangles versus the non-winter paintings, the blue squares.
That's great.
So you can see it's not perfect again, but there's a nice little region that has a bunch of winter paintings there.
That's awesome.
Yeah.
Yeah, so it's definitely getting something there.
We can look for more, but that's, oh, sorry, what was that?
It's definitely picking up on something. So it's not just always guessing non-winter. I think that's a nice way of visualizing what your classifier is doing. So it's some of the non-winter paintings it's incorrectly classifying. So that's actually good. And then it's missing some winter paintings that use similar colors to the non-winter paintings. So that's nice too. So yeah, looks like it's doing something interesting potentially.
Oh, cool. That's great news. And we can, if I change this code again back to words so it makes sense. There we go. We can look for like winter and conifer. Oops, that has to be a string. And then you see we'll have sort of 4 conditions here. We'll have 0, 0 when it's neither winter and nor a conifer. It'll be winter conifer when it is winter and there's a conifer in the painting, 0 conifer, and then winter 0 when the opposite is true. Although those don't happen a bunch, as we will see here. So there is almost never a winter painting without a conifer, which is kind of funny. And then you get a nice split here between the conifer and the neither are true categories, but there's also, due to the fact that there aren't many winter paintings, there aren't too many that are winter and conifer. But I don't know if this is from bias again or different things, but it looks like it's still above chance. Would have to dig into why it is above chance in the future. But we did run into problems trying to get this to plot nicely down below using the same sort of setup. So that's a work in progress. Another cool avenue that we thought about would be to make similarity matrices with the vectors, the binary vectors of colors used in each painting, and then based on semantic similarity of titles, and see if those had, if there's any relationship between those. But that seemed like a little bit too much to chew on in the class time that we had.
Yeah,
but that would be a future direction.
Cool. Yeah, very cool.
Yeah.
Cool. Well, yeah, thank you for going through that. That was really neat.
For sure.
Nicely done. Lovely. Okay. Okay, so let's continue on. So on Friday, you had asked me to like kind of give you some more experience or exposure to a couple of libraries. So for today, I put like sort of a roadmap together to help us get a bit more experience with specifically pandas and scikit-learn, which are two very, very popular Python like data science libraries. So let me share my screen. All right. Okay. So I again put a collaboratory notebook together. And the way I organize the notebook that I'm showing you here, so I posted a link to this in Gitter if you want to open your own copy of it. So I give some background about these libraries that's partially redundant with stuff you've already read over, but I think it might be useful to actually read it because I don't know, just another way to think about these libraries. Anyways, so there's that. And then I tracked down 3 data sets I thought would be useful for kind of learning about pandas and scikit-learn. So the first data set is about passengers on the Titanic. And the second data set is about guests on Jon Stewart's Daily Show, which is an older show that used to exist, doesn't anymore. And then the third data set is about Super Bowl ads. So near the beginning of the notebook, I include some code for downloading and reading in these data sets. And then as you scroll down, you'll see a bunch of, I call them missions, like Mission Impossible, where each mission kind of requires using some core set of functions in pandas or scikit-learn. And so you can think of each mission as a little mini problem that asks you to carry out a very specific task or analysis on one of these data sets. So the way that I want you to think about kind of learning more about these libraries is that depending on the library, it's usually either impossible or pointless to try to memorize everything about how that library works. So instead, what most data scientists or research scientists do is they, when they use these libraries, is you kind of develop basic intuitions for how the toolboxes are organized and kind of the logic driving the toolboxes. And then the most important thing is to develop good strategies and heuristics for quickly searching for the functions you're looking for. And so that's what I want to give you some practice doing. And then another really useful skill that I want you to practice is reading the APIs or the application programming interface for these toolboxes. So the API of a toolbox or a library provides a kind of skeleton set of instructions for using every function and defining every class that's specified in the library. And so the way I generally work is if I'm getting pretty deep into using a particular library is I'll keep one tab, the API for that toolbox open in one tab of my browser. And then mostly I use that to figure out which functions are available and what they're called. And then in another browser tab, I'll search for examples of how to use the different functions as I need them. And then coding is kind of this continual process of adapting examples that I find to fit the needs of whatever project I'm working on. And sometimes it's totally okay to end up with some Frankenstein's monster sort of hacked together ugly code thing that's made up of random snippets that I found that are coerced into working together. And then other times, you know, I end up like really polishing and adapting the code I find, so it, you know, the final product looks more cohesive. For, you know, the purposes of this class and most of like what you'll likely find yourself doing in, you know, research labs is like, the critical thing is that your code does what you want it to do, not so much what it looks like. And so that's what I'd recommend focusing on. But you know, you get bonus points for making your code pretty or intuitive or efficient and stuff like that. Anyways, I've outlined in the notebook some, like I call them like mission parameters, a set of kind of heuristics for approaching these missions. So I recommend taking a look at that. And then what I thought we could do is split off into breakout rooms and then like tackle a few missions at a time, like one per breakout room in parallel. And then we can converge as a group and tell the class about what you did and how you got stuff to work or where things went like horribly wrong. And then we can keep doing that until either we run out of class time or until it stops seeming useful. And then I'm also like happy to do one mission together as a class to get us started if you want to do that, or we can just, you know, go right into breakout rooms. So how would you like to, what are your thoughts on that? Do you want to do one mission as a class together? Do you want to go right into breakout rooms?
I think
Yes is not.
Mission as class.
Sorry.
Oh, I was just saying, I think starting with a class mission is great.
Okay, sure. We could start with a class mission. Should we just do the first mission then? I guess you haven't seen any of them. Okay, so okay. Okay, so the first thing I'm going to do is just like run the full notebook. So that'll like load in the data and stuff like that. Okay. Okay, so first we have to kind of get oriented to the data sets. So the way the Titanic data set is organized is it's like each person is a different row, and then each person gets like a bunch of properties or attributes, like did they survive, what passenger class were they in, their sex, age, possibly how many siblings, I don't know what SIBS P stands for, maybe how many siblings. I don't know what P arch means either. The fare they paid. Don't know what embarked means. Their class, like which class they're traveling. Like I think it's first, second, or third. Who is like kind of an interesting name for an attribute, but it's like man, woman, child, I think are the unique attribute or values there. And then if they're an adult male, that's kind of interesting. The deck they're on, the town they embarked from, whether they are alive at the time the data set was collected. So like you have to have survived for that to happen, unless you have a time machine. And then whether they are, which I don't think any of them did, and then were they traveling alone or not? Okay. Anyway, so kind of interesting stuff. So you might predict like, I don't know, kind of favorite thing to do with this data set is say like what properties might have led people to survive the Titanic disaster, okay, etc. Okay, so that's the Titanic data set. Well, okay, I'll just quickly overview the other ones. And then the Daily Show guest data set like lists the year, date, and guest name of each guest that appeared on the Daily Show. And then it also has these two other interesting attributes, like what's the occupation of that or like what is that person known for? And also it has like a category of person that they fit into. So like, are they an actor? Are they involved in acting, or like comedy, musician, politician, etc. Okay, so that's that data set. And then the Super Bowl ads data set has like a bunch of years. So like which Super Bowl year did it come from? The brand that produced, or that the ad is for, the website for the ad, the YouTube URL, and then like a bunch of properties of the ad, like was it funny? Did it show the product quickly? Was it patriotic, etc.? Okay. That makes sense? Okay. Okay, so the first mission here is we're going to use group by to create a data frame of the average probability of survival, fair, age, proportion of males, and probability of traveling alone by deck and passenger class. Okay, so yeah, how would you all? So the group by function is like a pandas function. Well, okay. So the first thing we have to look for is like the pandas API. Okay, and then we want to look for the group by function. And that's this. Okay, so this is like what the function is and how you use it. And you can see like you can see kind of what I meant by skeleton here. So it's like pretty minimal documentation. Like, I guess it does have examples. Often they don't have examples. But it's like, you kind of know, I mean, this is kind of, ambiguous, I would say. It's not super detailed, these descriptions. They're somewhat sparse. But what it's doing is something about like organizing a data frame. So if you wanted to dig into this, you could like do a Google search for pandas group by and try to understand that more. Or you could like look at the examples they give and try to start like understanding, okay, what are they doing? So here, they have this sample data set where you've got like animals and their top speeds, max speeds. And, oh, it must be individual examples of animals. So like individual exemplars of falcons and parrots. Okay, so Falcon 1 has a top speed of 380 unitless things, miles per hour, meters per hour, multiples of C per hour, I don't know. But anyways, that's how fast they go, 380 somethings per something per unit time. And then parrots, by contrast, go, well, one goes 24 somethings per something and the other goes 26 somethings per something. Maybe miles per hour, kilometers per hour, something. Then you can group by animal, and that will take all of the unique values of in that given column and assign each unique value to a row. So one row is falcon, one row is parrot, and that gets you this part of this function here. And then the mean at the end takes all the other columns that are in the data frame And for all of the rows that had falcon as the animal, it's going to take the average of the other columns and put that as the value for that rows column. So in other words, like falcons, there were 2 falcons, their max speeds were 380 and 370. If you average them together, then you get 375. And so 375 goes in this entry here. Does that make sense? Who have I lost here? How can I unlose you? Jane, the partial hand raise, I don't know. Do you wanna, did you have a question? No, you're just kind of stretching. Okay, no, you don't wanna ask because I'm embarrassing you. Great, no.
It's okay.
Okay, all right. Likewise, there are 2 parrots. The way you get parrots entry in the max speed column is you take all these values and then you apply the mean function to them. Okay. So that's how it works. So if we wanted to group by deck, let's see. So first we could remind ourselves, what does the Titanic data, data frame look like? Okay. So these are the like things in there. And then we're going to want, let's see, probability of survival. So survived. Let's see. Fair, age, well, okay. Proportion of males, we're going to have to do something for that one. And then probability of traveling alone. Let's ignore the males one for now. So what this syntax does is it selects out just the columns, just a subset of the columns. Okay, so that might be useful. Okay, now if we want to group by deck, we'd have to add deck as something that we're selecting out. Okay. And then if we want to group by deck, then we could do group by deck like this. This will be a grouped by object. Interestingly, it's actually like if you dig into it, it's actually like, has a little, oops, kind of like a dictionary there. Oh, is it just called groups? Yeah, so these are like the unique decks that are not nans, that are not missing. And then the values are like which indices in the original data frame correspond to those groups. And if I want the average, I can just use mean. So this will say for each deck, what proportion of people had a 1 in the survived column, what was the average fair, what was the average age, and trues are converted to 1s, falses are converted to 0s. So what proportion were, I guess it would be, proportion of people traveling alone. What's missing here is proportion of males. So to, okay, first of all, is this making sense so far? Okay. So how could I add in, so if I just like took the average of the sex column here, there would be nothing to, actually it would just be totally ignored. Like pandas doesn't know how to do anything with strings. So that doesn't work. So one way of handling this would be to like use the apply function. to add a new column that's like, you know, it could be like male or something like that. And then, let's see, how does the apply function work? So you apply a function along some axis. Okay. Oh yeah, great. And then we could say return a 1 if the, well, I don't know what this will do actually. Great, okay. So what we're doing is we could write a lambda function to return a 1 or true if the string matches male and a 0 and a false otherwise. And then we're applying that to this sex column. And then we could add a new column to the data frame, male, where containing those values. And now the data frame will now have this new column in it, named what we called it. Okay. So now, once I've made that change, now I could include the male column here, and then it'll include like the proportion of males in each deck. Okay. And then similarly, now if I want to do the same thing but by class, I could say like group by class, and then I'd want class to be one of the things I select out. And here are all the same stats, but now grouped by class instead of by deck. So you can see like it was good to be in first class because then you had like a, you know, greater than 60% chance of survival. It was bad to be in third class because then you had like less than a 25% chance of survival. But you also paid more, were likely to be older, less likely to be alone, and less likely to be male if you were in first class. Interesting. Yeah, there you go. So that's how it works. Yeah. Did that process make sense? Like could you imagine doing something like that in breakout groups? Okay. Okay.
Could you,
yeah.
if you don't mind, could you elaborate on like how to like, I don't know, like interpret API? Because sometimes I feel like when I look at the skeleton they provide on API, I'm like, what am I supposed to understand here? So I just want to know if there is any better way to understand it.
Yeah, that's a great question. It's often very hard to understand APIs if you're using an API to like learn a library, it's really hard. If you're using an API to remind you of something you already know, then it can be useful. I think so like here's how I look at this function. So or this kind of description. So data frame I know is like a pandas data frame object. And I could learn more about it by clicking data frame. And then I'm like, okay, this is well, this is not super descriptive, but okay. Anyways, if I knew what a data frame was already, then I could know that I'm applying it to a data frame object. So this is an operation that that comes with a data frame object. Function is a function, so it's going to be some function that I pass in, as opposed to like another type of variable or data type. What I don't know from the API is like, so it says apply to each column or row, like what's the input to those functions? Like, is it a list, an array, another data frame? Do I get one column or many columns? That's not covered here. Axis, so I have some prior knowledge there of like, okay, I know NumPy likes to have us specify axes. So if you know the NumPy library, like the axis tells you like which dimension to apply the operation down. So if it's like axis equals 0, that's like down dimension, or like the first dimension, like because it's 0 indexed. So that'd be down the rows. If it's axis equals 1, that would be like across the columns. And data frames can only be 2-dimensional, so those are your options. If you don't specify, I guess default 0 if you don't specify it. So it goes down the rows by default. Some functions might not have a default, in which case maybe it would get applied to like all the entries and you just get a single number at the very end. Some NumPy functions do that, for example. Raw, let's see. Oh, interesting. So I guess this must be something that gets called within apply, which allows you to either say, does whatever like subset of the table gets passed to your function, is that going to be converted to a pandas series object, which is like a one row or column table in pandas, or like a one row or column data frame, or is it going to be the like underlying NumPy array, which is like just the values. So like, in other words, like, do you retain the labels or not? And then I guess false means you retain the labels, true means you just pass the values. Oh, interesting. Here you have some control over whether the result gets turned into a single number or just, or it gets like returned as like a row of a data frame. So that seems useful. How these things work, not totally clear to me from just reading this. Here are some additional, you can pass in like a list of additional arguments to your function. That could be useful. And then a dictionary of keyword arguments you can pass to your function. So if you want to modify, like you can imagine using this if you have like, if you wanted to do like if anyone's familiar with like databases where you might want to like have two tables where things are stored, and you want to like modify one table or create a new table based on the contents of two tables, you could like pass in the other table as like an argument or keyword argument. That could be interesting. And then what gets returned is a series if the outputs of your function is a single number, and a data frame if the output is like I'm guessing if you use like expand is true or broadcast is true. Yeah. Okay. Anyways, you can kind of see like so you draw a lot on prior knowledge. So that's not super useful if it's like the first time you're looking at the API. The other trick is to say pandas apply example. You just Google it. And then Okay, there's some tutorial, and we can see if it's, okay, it's free, it doesn't require us to pay. So we can go through it with some other example. This isn't exactly the data set we're going to be using, but like it's a data frame, so that's good. It's got numbers and strings, so that's kind of like fits with what we have. Now let's see how they work this. And then the trick is you want to find when they actually call apply here, which is here. And so that's the line, that's like the target of our understanding here. So we want to say like, how, like, what's the input to this function? What does like raise df look like? And what does the output look like? And that's kind of what's involved in understanding how they're using it here. Doesn't mean that's the only way to use this function, but that's kind of a good place to start. Yeah, there's a lot of like exploring and flailing around, and that's part of using these things. Pandas is a very, very feature-rich library. You can't really memorize. I haven't even attempted to memorize it. NumPy, which is built on, is a very feature-rich library. Not worth memorizing the API of NumPy. You just like constantly Google things. That's my experience. Okay. Okay. Okay, we're pretty much out of time for today. Okay, so maybe we'll do some missions on Wednesday, and then if you like it, then we can do it on Friday also. But let's wrap up for today. If you have to go, you can go. But I wanted to get your thoughts on another thing, which is we're kind of like getting into the home stretch of this course. So we're in week 7 now. So we have a little under 3 weeks left. And we're currently on module 4. So I want to spend at least Wednesday on module 4, especially like while assignment 4 is still out, and to give you some more practice that you requested with pandas and possibly scikit-learn. But what I was hoping to get your input on is like where you want to go from here. So we kind of need to pick and choose from the remaining modules. So what I'm hoping that you can do is for Wednesday's class, I'd like you to take a look at the modules, modules 5 through 10 of the course and see what's most interesting to you. And then on Wednesday, we'll talk about like a plan for what we want to focus on for the rest of our time. Of course, you can go through the rest of the material on your own, but how we spend our class time, I want to like focus on things that you're interested in. Okay, so please do that for Wednesday, and then we'll talk about it. Okay. All right, that's all I have for today. So on Wednesday, we'll talk about a plan for the rest of the class and do some of those pandas and scikit-learn missions. Okay, so see you tomorrow or during my office hours or in class on Wednesday. Take care, everyone.